colleagues. Today, Mukhlis, Salim, and I will be presenting our project, which is a 3-axis crane but using hydraulic system. But before we start, we would like to thank Dr. Samir Albert Khayyat for guiding us throughout the semester.
In this process, we're going to talk about our project, which is 3-axis crane using hydraulic system. We're going to discuss our objectives as an engineers. While doing so, we're going to show you like a schematic, and we're going to show you results. We're going to show you a short video and an explanation. Stay tuned.
In this project, we will recreate a 3-dimensional hydraulic crane using syringes and tubes to represent the hydraulic movement system, and using cardboard and wood to build the base and the structure of our crane. The main objectives of our project are as follows: to design and implement the crane with its claw using the methods and formulas learned in our solid mechanics course, to design and implement the crane on Tinkercad to check for the maximum lifting and loading force before collapse, and to make a real-life prototype that could be used in our future everyday engineering world.
Now we'll be discussing the background of our project, in which we use hydraulic system. Hydraulic system is a system that relies on the forces applied to a field containing a small cylinder at a high pressure. So as the figure shows, we have two cylinders, cylinder A and cylinder B, connected throughout the tube, in which if we put some pressure at the first cylinder, it will push the water throughout the tube till the second cylinder, and that we can call it Pascal's law that we used in our project.
Now we will discuss the 3 main types of cranes. The first type is overhead cranes. Those cranes have their hoists connected to a rail and can lift masses greater than 10 tons. The second type is fixed cranes. Those cranes are used for their strength and their durability and can lift masses to very high heights. The third and final type is portable cranes. Those cranes are movable and can work under different conditions, such as on roads, on bridges, etc.
So about the materials that we use in our project, basically most of the materials we can find it at home. So we used wood, barbecue stakes, wood stakes, a glue gun, and cardboard, and some syringes and tubes. Now, considering the schematic explanation, we'll be explaining how our project works. So since our project is similar to the human arm, but the difference between them, the human arm has 7 degrees of freedom and our project has only 6. And those 6 are moving up and down, moving left and right, moving backward and forward, swivels left and right, tilts backward and forward, pivots side to side.
As a result, our 3-axis hydraulic crane is able to lift many objects such as a water bottle and Pepsi can, and many also things which is not heavy. It's a prototype actually. We didn't use any external power. We just used a mechanical power. It's just to help us understand the method and the concepts behind the forces and behind the how the mechanics is used. So it's many prototype crane to help us understand how they use like a big cranes in the construction site.
In conclusion, this project provides a very simple and easy way to create a versatile hydraulic crane using recyclable materials found in our everyday lives with the help of fluid and solid mechanics. I would like to thank Dr. Albert Samir Al-Khayyat in helping us and leading us through the solid mechanics course, and to thank my teammates and colleagues Ali Salman and Muhammad Shomal in helping me in doing this.
explain a little bit about the project, since it's a 3-axis robotic arm crane. So there is 6 degrees of freedom. Usually you don't see that. We just see in the construction sites, we see like 4 degrees of freedom, which is either for the heavyweight duty crane or the lightweight duty crane. So how did we implement that? We implemented that actually using Pascal's law and using formulas we learned in solid mechanics, and we used actually a little bit of fluid mechanics. Basically, we didn't take that actually in the class. We just tried to learn by ourselves in the on the internet. So it was hard to implement because we didn't take fluid mechanics. So it's hard to implement, especially when using the syringes and the tubes, so we can let the crane move by itself without using our hands. We tried our best. And what is the main point of this project? The main point of this project is actually to make the life easier. Especially that we're engineers, we try to facilitate the life of the civilization. So the main point is for the construction sites, actually, basically because you don't see 6 degrees of freedom in the construction sites. You only see 4 degrees of freedom. So this is a helpful crane. It's only a prototype. So if it is possible to make that kind of cranes in real life implementation, for the construction sites, it will be amazing. You will not need any workers in the construction site. You will need a little bit less workers. So that's it for our project. I hope you enjoyed.